Welcome back, everybody. Today we're gonna be trying to revive this poor Lexar S75 flash drive. Recently one of the videos almost got 50,000 views, and I don't know exactly what was about that video that was different than everything else that I make, which usually on average gets about 6,000 views. Smash the like button, leave a comment. I'm confident that these things, they do affect how videos end up doing. It's gonna be fun for several reasons. Reason number one is it's busted wide open. Somebody smacked it really hard when it was connected. These two cuts, you see these two cuts, one on top and one on the bottom, here and there, basically destroying all of the connections, at least on 3 sides of this controller. And this controller has lots of connections. This is gonna be a nightmare. The video that I made, the one that I was talking to you about, that did amazingly, let me bring it up. And in that video I explain how any flash drive can be repaired by using the technique that I show in that video. In order to do that, you need to have a donor unit, and in order to have a donor unit, you need to have something that is built on the same production line as what you have to repair. Unfortunately, this is a 256 gigabyte flash drive that wasn't cheap. I checked them out right now. If we find one on Amazon, 256 gig Lexar S75 flash drive, it's $100. And if we want to match the color, it's 260. I don't even know if it's gonna match. Like, we may end up spending that money and still not get a proper donor, and that's the problem. That if you don't know whether or not your donor is gonna be an exact replica, you may just end up with something that you just bought that you can't use to help your case. I went through all my Lexar boxes. I've dug out all my 256, all like 5 of them, and none of them matched. So all of them had components on both sides. As you guys can see on this unit, we only have memory and a controller on one side, and pretty much empty circuit on the bottom where the connector is. So pretty sad for us, because I don't have a donor. So the technique I showed in the video that did so well is actually not going to apply here, because I won't be able to repair this unit by simply swapping over the memory. So how are we going to deal with this? The technique that we're going to use is going to be just plain stupid repair. There's nothing wrong with that technique. There's nothing bad about it. It's just it's time consuming. But right now it's the only option that I want to pursue. Yes, we could take out the NAND, which is right here, put it into an adapter like PC3000 and read it out and try to build the logical image out of the physical image from the NAND, simulating the controller. But I don't want to go that route. You might want to find out why, right? Simple. It's 256 gigabytes of misery, guys. It's 256 gigs that need to be read, which is gonna take at least a day if I start early. Then it's gonna take another day to error correct probably, and that's assuming that it's gonna give us a clean read on the first go. It probably will, because the damage on this device is clearly related to the physical impact. But what if it's not a easy to read chip, and it likes to produce a lot of errors, and it likes to have a specific read retry, and it likes to do work only under certain voltages? It could turn into a sticky mess. So I'm gonna repair it. So let's have a look at it. First, we need to assess what is broken, and obviously this thing is broken. but we also could have a memory that got affected by the flex and also got beat up as a result. So I'm gonna start by removing both of these chips, not just one but both, and assessing the damages all around. Okay, so we're definitely gonna come back to putting the memory back on there through the Reball, but first I want to know whether or not this memory is fully connected. We may redo the whole controller, plug it in, and just find out it doesn't work. And the whole reason why it didn't want to work would be because the memory was not connected, and at that time it will be too late, because the technique I'm going to be using we will need to be sure that the memory is attached. You'll see why. So I'm preheating this at 385. Not preheating it, but heating it up rather. This is a big chip, probably 8 crystals in there. Okay, for the memory we're gonna put it in here, and the controller okay, it looks like one side only survived. It's becoming fairly clear to see like how much work will be involved. I don't want to say it's a lot of work, because I mean, to some guys who work on iPhones and things like that, where things get really banged up, this may not seem like it's a lot of work, but I don't work on iPhones, so for me it is a lot of work, even though it may just be like a few signals. So I guess let's count them up. So this is not connected, we're not going to care about that. Not connected, not connected. So there's one that needs to be redone. There's two that broke off right there. 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. $18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29. So 29 are broken. 29 are broken and the rest are good. How many do we have in total? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. 16 times 4, 64. Same way as I usually clean up the memory, I'm gonna clean the controller. Because it's got a lot of broken off pads, I'm gonna just dump a bunch of tin into it first. We're not gonna need to reball, retin, or do any sort of nonsense with this one, and I'll explain why. Because there are so many broken pins, I'm not gonna try to repair pads on them. I will be doing connection by wire. It's a bit more primitive and obviously not as technical, but it's gonna give me a reassurance that what I've done doesn't have a extra room for error, because I'll be able to probe everything. I'll be able to make sure that it's connected correctly. With repairing pads, I won't have that luxury. I won't be able to make sure that all the pads are making contact once the chip goes back on. So clean up the memory. Look at this. Nice. It's a process I've shown on this channel many times. It's called the Reball, and this is a pretty standard memory chip. To do this on, get our hot air out. Look at that. Perfection. So for now, let's address another elephant in the room, and that's all of these broken connections. Because once the chip goes on them, I don't want to be scraping the stuff off the leads, so let's just do that now. I'm already not excited. Well, I am kind of excited to fix it, if it's gonna be fixed. But whether or not that will happen, I don't know yet. I mean, this is a complex board. It might have damages somewhere in the middle, and something may still be disconnected. So I'm like, I mean, a lot of things right on the on how far this damage went. You know, I feel like this is also connected to us. Yeah. Luckily for us, the entire row close to the connector survived, and for the most part this left side is also clean-ish. Oh, that's good enough for me. Let's get some flux up here. And like that. the chip has a dot right there. We're gonna put it right where that slanted corner is. Now the solder that we applied is leaded, so it's gonna melt much quicker. We don't have to wait as long as we did to remove it. There we go. So it was mounted like this. The dot is right there and the slant is right there. So if we were to position it, like, we can obviously not place it here because there's some wires go under the chip, like here, and I will not have ways of connecting them back. So what I'm gonna do is I'm gonna flip it over to the side like this, and I'm gonna run wires off of here. Can you see how thin this wire is? That's just what's gonna be making our work a lot easier. If the wire is thicker, it's gonna be harder to manipulate it. It will take longer to burn the coat off. This wire is just amazing. So fume extraction is on. I'm gonna put on some music because this is gonna take me a while.
One hour later.
Alright, time to test this out. So I'm gonna plug this in. To the meter first. Yeah, the problem is the meter shows us the bottom side. I have to hold this upside down. And the moment of truth. Something is not connected. We're getting the controller is hooked up, but the memory seems to be off. This is where I begin to think that maybe spending that $100 on the donor would have been a good idea. I'm gonna go over the contacts once again, just run them through, make sure everything's connected, because this would be safe mode, and if we're getting safe mode, that means it could be just simply one signal is not connected to the NAND, and that's the result we're getting. So yeah, this case, unfortunately for me and my easy way out, did not work to my advantage. I've ended up taking everything off from this board and redoing it from scratch, mounting everything back just to see the exact same result that was obtained already. At this point, I am more than confident that something on the board is fractured, disconnecting the NAND from the controller. Controller comes up, I can see safe mode, it's doing what it's supposed to do when the NAND is disconnected, but how to connect that NAND, to controller in a simpler way, I have no idea. There will be a sequel coming out to this video where the recovery will be performed using NAND extraction. I did order that unit from Amazon, not the $260 one. I got the $100 version one, even though the ad said it was a S75 flash drive. I was like, okay, well, let's just gamble on it. If it doesn't work, it doesn't work. But they ended up sending me S80, which looks completely different, and I don't even know why they even have this ad posted, but it was definitely not 75. I couldn't use it. And I also followed up with the client to find out if maybe they bought more than one. Sometimes these flash drives come in like a 2-pack. I did test the readout, and the readout works. So that was my biggest scare, is that we end up with the chip that we can't perform error correction on clean enough to produce good copy, and that would be just kind of, you know, rendering all that invested time useless, because without corrected physical dump you can't assemble good quality logical dump. So thank you guys for watching this video. I know this was a long one, but it was, like I said, one of the biggest damages that I've seen done to the controller in a long time. Now the second part of this video will probably come out in about a week. Gonna need to finish this case up first. It's like to the point of where this is edited and produced, I got nowhere with the data. This is just me letting you know, but I'm pretty sure that the day will come, and we'll get to see this case all the way through and bring back some good data from this device. Thanks guys for watching. I'll see you all in the next episode.